Hello, and welcome to the Intrepid Sea, Air, and Space Museum's live public programming. My name is Kara, and I'm a museum educator here at the Intrepid Museum, located in New York City, and I'm going to be leading you through today's program. Now, just as a reminder, the museum's live programming is free, so if you'd like to donate or support us in delivering this content, please click on the link located in the comments or the chat. Now, speaking of the chat, feel free to let us know where you're tuning in from. Have you ever been to the Intrepid Museum before? Or if you'd like to participate, ask questions, and answer some of the questions that I'll be asking throughout today's program. Now, again, my name is Kara, and I'm an educator here at the Intrepid Museum, where our mission is to honor our heroes, educate the public, and inspire the youth. So let's get started. So just to get us started with a little bit of background information, this is the Intrepid Museum. Now, what's really cool about our museum is that it's located inside of a historic World War II aircraft carrier, the USS Intrepid. Now, we're located on the west side of Manhattan on the Hudson River, right in between New York and New Jersey. If you're walking down the West Side Highway, you cannot miss us. The Intrepid is about 913 feet long. Just to kind of put it into perspective, if you were to play football on top, you could play 3 games of football at the exact same time on top of the Intrepid. If you were to take the Intrepid, put it on its side, it would be almost as long as a New York City skyscraper. Now, from that very tip top there, all the way down to its lowest deck, Intrepid is about 8 stories tall. So like I said, if you're walking down the West Side Highway in New York City, you can't miss us. It is massive. So a little bit of history of Intrepid. Intrepid began its construction on December 1st of 1941, 6 days before the bombing of Pearl Harbor. During its service, the Intrepid served during World War II, the Vietnam War, and the Cold War, but also did some work for NASA, which we'll get into in just a little bit. Now, looking at this large vessel that you see here, during World War II, it was very difficult, very impractical to send airplanes from the United States across oceans to fight during these wars. So things like Intrepid were built to help carry these aircraft. So can anybody in the chat tell me what this type of vessel would be called that's job is to carry aircraft? Now, not only was Intrepid carrying these airplanes, but they were also launching and landing on it as well. So let me know in the chat if you know what type of ship carries aircraft, the official name for it. So I see in the chat, if you said aircraft carrier, you would be correct. Like I said, not only was Intrepid carrying airplanes across the ocean, but they were also taking off and they were landing on it as well, just like a floating airport. Now, Intrepid served from 1943 to 1974 before becoming the Intrepid Sea, Air, and Space Museum in 1982. So just looking at this picture here, it's kind of a given why we are a sea museum, right? The Intrepid sailed in the ocean, carried these aircrafts, and was constantly in the water. Now, you probably guessed why we are an air museum, because we've got airplanes like this. This is the Avenger, and this was the primary plane of World War II and one of the oldest airplanes in our collection at the museum. So we're an air museum because we have a collection of airplanes and also airplanes launched and landed off the top as well. Now, we don't only have airplanes from World War II, but we've got jets as well from the jet age as we went into the Vietnam War. Now, not only do we have planes like the Avenger and planes like this, like the Fury, but we also have a Concorde and an A-12 on board as well as about over 24 airplanes in our collection. So that's why we're an air museum. But can you let me know in the chat why we're a space museum? Let me know why you think we're the Intrepid Sea, Air, and Space Museum. I kind of hinted at it earlier when I said that Intrepid did some work for NASA, but can anybody tell me why they think we might be a space museum? And I'll give you a hint. It has to do with this artifact or this replica right here. Can anybody tell me in the chat maybe what this is, or give me an idea? What do you think this is based on its shape? It kind of looks like an ice cream cone or a light bulb. I've also heard it kind of looks like a microphone that you can speak into as well. If you look at some of the details there, it's got some vents. It says United States on the top with the American flag on it. Let me know in the chat. It also looks like it has some rockets or maybe some boosters at the far right of it as well. So if you would have thought that maybe this was a vehicle or a space capsule, you would be correct. Now, this is a space capsule, and this is what helped the first American astronauts get up into outer space. It would sit on top of a Redstone or Atlas rocket before launching up. And I see John in our chat is saying a Mercury capsule, right? And that is correct. So back in the 1950s, there was something going on called the space race. And basically, these two countries here, the United States and the Soviet Union, or today they're Russia, right, were competing to see who could get somewhere first, right? It's called the space race. So let me know in the chat, where do you think would be a good place in outer space to maybe have that finish line, a physical place that you could land on, that you could maybe get to first, right? Now, the space race, you could say, officially started on October 4th of 1957 when the Soviet Union launched Sputnik, right? It was the first, or the world's first artificial satellite and the first man-made object to orbit around the Earth. So has anybody figured out where a space race finish line might be in outer space? If you would have said the moon, you'd be correct, right? The finish line was the moon. But during these early stages of space exploration, you can't just put astronauts in a rocket or a spaceship or a space capsule, send them to the moon and kind of say, good luck, I hope you make it. You've got to kind of take these baby steps, right? Can we first get into outer space? Can we send humans? Can humans orbit? What kind of things do you need to take up besides air? How much food? So like I said, you can't just get out of bed one day and get to the moon. You've got to take these baby steps. So NASA decided that they were going to break up getting to the moon in 3 different projects or missions, but the first being the Mercury missions, right? The Mercury missions had these 7 astronauts right here. And today we're going to focus on, Scott Carpenter there at the far right. And this was his capsule, Mercury capsule, or the Aurora 7, right? And like I said, NASA was trying to break up going to the moon, in 3 missions. You had Mercury, Gemini, and Apollo. So during these Mercury missions, this specific capsule here, the Aurora 7, sat on top of an Atlas rocket, blasted off together. The capsule would separate, orbit around the Earth before coming back down. So in 1962, Scott Carpenter rode up on the Atlas rocket. He orbited the Earth 3 times and was up there for about 4 hours and 39 minutes, almost 5 hours in outer space, right? This made him the 2nd American to orbit the Earth and the 4th American in space. So coming back down from his journey, right, you can see him here before his launch, actually launching. When he's ready to come back down to Earth, he's going to land in the ocean. Now, you're probably wondering, why the ocean? Well, it's a nice, soft space to land. There's also a lot of it. It's a huge target on Earth, right? The Earth is covered in about 71% of water, so it's a nice, big place to land. It's called a splashdown. So if you look closely, you can see that there are parachutes that are let out. That helps create some drag to help slow the astronaut and his capsule down before coming back down down to Earth, right? Slow them down, create a little bit of drag before landing in the water. Now, this astronaut, and Scott Carpenter, is going to be out in the middle of the ocean. So can anybody think of a large vessel that might be nearby that could pick up Scott Carpenter? Let me know in the chat if you know of a big, huge ship that could maybe deploy a helicopter to go pick up an astronaut that might be in the middle of the ocean. Let me know in the chat. If you were thinking Intrepid, You would be correct. But something very interesting happened that day when Intrepid was supposed to go pick up Scott Carpenter. While he was coming back from outer space, he got a little bit distracted looking out the window. Now, if it's my first time in outer space and I'm coming back down to Earth, I think I'd be distracted too. Right? So that caused him to push a couple buttons too late, 2 seconds too late, and he activated his retro rockets just a little bit too late, causing him to go about 250 miles off course. It took them a couple of hours to find Scott Carpenter. He landed northeast of Puerto Rico, but when found, these helicopters were able to take off of Intrepid, pick up this astronaut, and bring him back to the ship. And another ship would come and pick up the capsule. Right? So this is why the Intrepid is a space museum. Intrepid acted as a recovery vessel for NASA during the beginning parts of the space race. So now that we've learned a little bit about Scott Carpenter and the Mercury missions, are there any questions? Let me know in the chat if you have any questions. Why was it called Project Mercury? Oh, that's a really good question. So if you think about the name Mercury, you've probably heard it in space, right? Mercury is the first planet in our solar system. It also goes around the sun the fastest. It takes Mercury about 88 days to go around the sun. Now remember, this was the space race. We wanted a name that kind of proved that we were number one and that we were the fastest. So that's why NASA decided to name the Project Mercury, to kind of show everybody and kind of get everybody amped up that we're number one, we're going to get there the fastest. Good question. Any more? Did Scott Carpenter leave the capsule when he was in space? No. So Scott Carpenter didn't leave his capsule. His main mission was to go up on his rocket, orbit the Earth, and then just come right back down. Astronauts didn't leave their capsules until the next mission during Project Gemini. Good question. So speaking of Project Gemini, after the Mercury missions, Gemini was next in line. After everything that NASA had learned from Project Mercury, they were able to do and take things a little bit further. So during Gemini, things like spacewalks were able to happen, or extravehicular activities. So basically these astronauts were able to leave the capsules and be tethered to the space capsule, right? You don't want them floating away. They were able to last in outer space longer too. The longest mission with Gemini 7, they were up there for about 14 days. Now, can you imagine sitting next to somebody for 14 days? And I'll show you what that looks like in just a second. But Gemini 3 took up the whole Gemini project took up 2 astronauts. And Gemini 3 was these 2 astronauts here, Gus Grissom and John Young. And like I said, Gemini missions were experimenting with things like doing EVAs or spacewalks, staying in outer space longer, and eating food too. So on the day of their launch, Gus Grissom and John Young here, right up on their rocket, the Titan II rocket, they're orbiting Earth about 3 times. Right? And on the day of their launch, they sneak something up into outer space. So while they're orbiting around the Earth, John Young pulls out a corned beef sandwich on rye. Now, if you're here on Earth and you take a bite out of a sandwich, all those crumbs are going to probably land on your lap, right? But if you're in outer space, there's very, very, very little gravity, or microgravity. So those crumbs aren't going to land on your lap like they would here on Earth. They're actually going to start floating, right? And in 1965, space food was pretty gross. If you look at this picture here, I'll zoom in for you. You can see that it's dehydrated, it's freeze-dried, and it's bite-sized. It's also coated with an oil or a gelatin to prevent it from crumbling. So I don't know about you, but this doesn't look very appetizing. A lot of the time, water would have to be reintroduced. They'd squish it up and then slurp it and kind of eat it like that. And if you look closely, some of these packages, the one that's covered in foil there is chicken sandwiches. If you look in the top right, you can see that says bacon. on it. The one underneath the bacon says fruitcakes. So it's not the most appetizing meal, right? So of course, if these crumbs are floating, you're probably thinking, well, that's not the worst thing that can happen, but it kind of is. Those crumbs could get lodged into buttons, right? They can go into the ventilation systems. They can even get into the astronauts' eyes and ears, right? These missions were really important. They also had to get these astronauts back down to Earth safely. So this was a really big deal. So of course, when they got back down to Earth, they got in a lot of trouble. They had to personally apologize to Congress for possibly putting this mission in jeopardy. But something was learned from it too. You can't take bread into outer space. It's just gonna crumb and float. So today, if astronauts want to take food or take something that's going to be put on bread into outer space, they actually use tortillas. So you take a closer look at this picture here of Peggy Whitson. You can see that she actually has a hamburger on her tortilla. It's got mustard, it's got ketchup, and it's got onions on it too. So you can't take up hamburger buns, you have to take up tortillas. So I've never had a hamburger on a tortilla, so that would be a really new experience for me. But like I said, because of the Gemini mission, we know that we can't, or astronauts know that they can't take bread up into outer space, right? There's also no refrigerators today on the International Space Station or the ISS, right? If they, there is one refrigerator and actually holds biological experiments. So I don't know about you, but I wouldn't want to put my lunch in a fridge that's holding biological experiments, right? Also, astronauts tend to lean towards spicier foods. When you're in this microgravity environment, something called a fluid shift happens, and it causes the astronauts to feel like their head is congested or kind of like they've got a cold, and they tend to lose their sense of taste and smell. So they tend to lean towards food that has a lot of flavor and is a little spicier, right? So again, these astronauts went up side by side, just like this. They orbited the Earth 3 times. They went about 140 miles from Earth, right? And so when they're coming back down from outer space, can anybody in the chat tell me a nice, soft space that they could possibly land? The Earth is covered in 71% of it. It's the same place where Scott Carpenter landed. If you said the ocean or on the water, you would be correct. So again, these astronauts have to let out their parachute. It's going to create some drag, slow them down while they're coming down from space. And just like Richard said, they're going to land in the water, right? Because there's a lot of it. It's a big target. You almost can't miss it. You have to be trying really hard to miss the ocean, right? And so it's a nice soft place that they could land. So as those astronauts are, oh yes, I see Richard saying it is still a hard landing, right? Even if you're jumping off of like a diving board and you land on that water wrong, it's gonna hurt. So it's a softer landing than definitely landing on like the grass, right? So after these astronauts come back and they're waiting to be picked up, if you look a little closer on this picture here, you can see that there's this green dye coming out of the capsule, and that's so that they're more easily recognized and they can find them a little bit easier. But there's also that yellow kind of floaty around the capsule, and that's called a flotation collar. Also during the Mercury missions, NASA learned that if you're not careful, these capsules can sink to the bottom of the ocean. Now, Gus Grissom, who's one of our astronauts here on this Gemini 3 mission, was also an astronaut during the Mercury 7 missions as well. When he was coming back down from outer space, he landed in the ocean and his door or his hatch popped off accidentally. It started to fill up. His capsule was the Liberty 7. It started to fill up with water. Luckily, he got out just in time, but his capsule ended up sinking to the bottom of the Atlantic Ocean. And so it actually wasn't recovered until about 30 years later after it sunk. So it was down there for a while. But like I said, it's one of the reasons that NASA decided to put these flotation collars on the Gemini capsules so that they wouldn't do the same thing and sink. Gus Grissom decided that he wanted to name this capsule the Unsinkable Molly Brown after the Broadway musical to make sure that it didn't sink like his first one did. So While these astronauts are waiting to be picked up, can anybody think of a large, beautiful aircraft carrier that might be floating nearby that could, again, deploy some helicopters and pick up these astronauts? Anybody in the chat? If you were thinking the Intrepid, you'd be correct. And I did mention it earlier, right? The Intrepid picked up these astronauts. And you can see here, it's a really big deal. They were very excited to have astronauts on board and to be helping NASA as a recovery vessel, or helping NASA as a recovery vessel to pick up these astronauts and their capsules. If you come and visit the Intrepid today, you can actually see a replica of what that would have looked like, the crane picking up the Gemini capsule and bringing it on board. Awesome. So this is a great spot for a question break. Here we go. Oops. Were any other capsule programs named after Greek mythology? Yes. So we have, of course, Mercury, right, who is named after the planet, which is named after the, I'm tongue-tied, messenger of the gods, right? And then you had Gemini, who was named after the constellation of the twin brothers, the twins, right? And I see Richard also saying Apollo, correct, right? The god of the sun. So yeah, a lot of these programs were named after Greek mythology, but not only capsule programs, but rockets as well. They have names like Atlas, Pegasus, Saturn, Titan, right? And then the satellites are named after Greek and Roman mythology as well. Most recently, you've got Juno right now, who is named after the Roman goddess and the wife of Jupiter, right? And Juno satellite right now is orbiting around Jupiter and just recently took pictures of Jupiter's largest moon, Ganymede, who is actually named after a Trojan prince that Zeus, who is the Greek name for Jupiter, took to Mount Olympus to be a cupbearer. So yeah, NASA loves to name a lot of their capsule programs and a lot of their rockets and probes after Greek and Roman mythology. I like to think that they are the original kind of owners of the sky. So it was really neat to kind of give all of these new programs those Greek and Roman names. Good question. Do they eat better food in space now? Yes. So a lot of it is still dehydrated, but they can actually take up things like fruits that don't have to be dehydrated. They can take up brownies as well. A lot of things do have to still be introduced to water, like macaroni and cheese or spaghetti. Things like salt and pepper that we kind of take for granted here on Earth, right, have to be in liquid form in outer space. Again, you don't want salt and pepper floating around, have all these particles. Could you imagine getting pepper in your eyes? It's already hard enough when it gets in your nose, right? So that has to be in liquid form when they're putting it on their food. Like I said, they don't have refrigerators, so everything that they take up has to be able to last without being put in a fridge. They also have a team of nutritionists that make sure that all these astronauts are getting all their nutrients and vitamins as well. And I heard recently that they were able to bake cookies in outer space, but it took them about 2 hours to do that. So I think after being in space for a while, it's worth waiting the 2 hours for cookies. Good questions. Awesome. So just like Richard Train mentioned in our chat, right, after the Gemini missions, we went on to Apollo. I'll make that a little bit bigger for us. Now, this was the third part of the three-part series to get to the moon after Mercury and Gemini. And like I said, during the space race, we wanted to get to the moon. Now, 6 Apollo missions achieved this goal with the famous Apollo 11, who you can see there, landing on the moon on July 20th of 1969. Now, looking at these astronauts here, can anybody tell me the name of these 3 astronauts? 2 of them walked on the moon, and 1 of them orbited the moon, waiting to pick them up and bring them back safely to Earth. Now, while you're thinking about that, all the work of Mercury and these Gemini missions and their experiments and their testing led up to the successful landing on the moon. Right? Without those first 2 missions, we would have never been able to get this far. Again, you can't just get up one day and hope that these astronauts land on the moon for the first time. You've got to take these baby steps to eventually get to your goal. So as we're looking at these astronauts here from left to right, you can see that we've got Neil Armstrong, you've got Michael Collins right there in the middle, and Buzz Aldrin. So like I said, Neil and Buzz were able to walk on the moon, while Michael Collins was kind of like the getaway driver. He orbited around the Earth, waiting for them to be picked up, and he would bring them back safely to Earth. So, like I said, 6 missions were able to bring back over 400 kilograms of lunar samples. They did research and experiments on things like meteoroids, solar wind experiments, and so much more. Now, I mentioned that the point of the space race was to see who could get to the finish line first, being the moon, right? And the U.S. landing on the moon effectively won the space race that began almost 10 years earlier with the launch of Sputnik. So now that we know a little bit about the history of what it takes to get to space and the space program and what it took to get to the moon, let's think a little bit about what it might be like to live in outer space. So let me know in the chat, what are some things that you know about space? Maybe about the gravity or the air. What's it like going up there? Could you leave a space capsule without a spacesuit on, or the ISS? Let me know in the chat. What are some things that you already know about outer space? So Richard says that it's cold and it's very dry. Awesome. So here on Earth, we have lovely things like gravity, right, that hold us down to the Earth, that keep us from floating away. Whereas in space, like I mentioned earlier, there's very, very, very little gravity, or microgravity. And that's what causes, or while the astronauts are basically free falling, causes them to float in the International Space Station, when you see all those really cool videos of them doing that. Here on Earth, we also have another lovely thing called air, right? It allows us to breathe. But in outer space, we know that there is no air. And so when astronauts are doing EVAs, they have to make sure that they are all suited up, make sure they have their air with them. They can't just leave the capsule without wearing a spacesuit. And it allows them to breathe and protects them from the vacuum and the elements of space. Now, here on Earth, we are also protected by this nice bubble that contains all of our air and allows us to breathe, our atmosphere. Now, that atmosphere is held in place by gravity, and within the atmosphere, all the air around us has weight. Now, that weight is exerted on everything on the planet. Now, we don't feel it. You don't feel the weight of air pressure on you because we're used to it. But if you wanted to kind of think about it, think about like a chunky cat, right? A 15-pound cat on every square inch of your body and on everything all around you. Again, you don't feel that 15 pounds of pressure per square inch because we're used to it. We live on Earth every day and we don't leave Earth's atmosphere. And we're constantly under this pressure, right? So what I've got here, and I'll make it a little bit bigger. There we go, is we're going to kind of imagine what would happen if we took all the air out of Earth. We're going to create an experiment here of the conditions of outer space and the effect that it would have on your body. So if you see my bell jar here, you can see that it was connected to a vacuum. And inside we have a jar, a container of water that is room temperature. So what we're going to do is we're going to turn on that vacuum, and it's going to take all the air out of this container. Now, I'm not taking out the gravity, I am just taking out the air pressure. So tell me in the chat, what do you think is going to happen to that water if we remove the air pressure or the air? We're creating a vacuum, like the vacuum of space. What do you think would happen? So as you can see here, these bubbles are starting to form. And you can see that the water has kind of started to boil. Matter exists as a solid, liquid, or gas state, and air pressure from the atmosphere keeps all these molecules compressed in a liquid state. But if we remove the pressure, like we did in this vacuum chamber here, there's nothing holding those molecules together, and they're able to spread out and create water vapor. So think about what would happen to your body, right? Our bodies are made of about 60% of air. What would happen if you removed all the air pressure? Think about maybe the saliva on your tongue. It'd start to boil, right? So if we were to touch the water inside of this container here, trust that it is still room temperature because we didn't actually heat it up. We just removed that air pressure, letting those molecules be a little bit more free, and we're able to move around. So next, we're going to put 2 balloons in here, and these are going to represent our lungs. Now, let's say that you're in space and you're in maybe the ISS, or you're in your own capsule, and for some reason it has windows that can open, right? And somebody decides that they're going to open a window. In the time it takes you to run over and close that window, do you want to take in a deep breath like the red balloon and hold a bunch of air in your lungs while you're running to close that window? Or are your lungs going to be like the blue balloon, where you're just going to blow out all the air from your lungs and try and keep nothing in there? Let me know in the chat. What would you do? Take in a deep breath of air or let all the air out? Awesome. So as we connect this to our vacuum pump, you can see something really interesting starting to happen to the red balloon that had a little bit of air in it, right? Like I said, this is representing our lungs. Taking a deep breath of air, or are you going to let all the air out? Yeah, and I see Allison in the chat is saying she's going to let all the air out, right? So eventually, looking at this balloon here, if this was your lungs and you're out in the vacuum of space, again, there's no air pressure holding that air together. So those molecules get excited. They want to run and jump around. And eventually, this balloon would pop, or your lungs would also pop too if you had all that air in there as well. But of course, being in the vacuum of space, it wouldn't make any noise, right? So now that we see what the vacuum of space does to water and to balloons, we're going to put a marshmallow inside of our vacuum chamber. Now, we know that marshmallows are basically made of sugar, air, and water. So let me know in the chat, what do you think is going to happen when we start to remove the air from our vacuum chamber? Looking at this marshmallow here, you can see slowly that our marshmallow is starting to expand and get a little bit bigger. And that's because those air molecules are going to be able to expand, right? But something interesting is going to happen when we reintroduce air to the marshmallow. Let me know in the chat. Do you think it's going to continue to get bigger when we reintroduce air? Now, remember, all of these pockets that our marshmallow had are now gone. So when we reintroduce that air, our marshmallow is actually going to sink, and it's going to shrink into this little kind of dehydrated marshmallow, right? So as we discussed about NASA doing these baby steps to get to the moon and doing experiments and making sure that just their spacesuits were secure, because imagine if you had a hole maybe in the glove and all of the air was being removed from that astronaut's spacesuit. What's going to happen to the saliva on their tongue? It's going to boil. What's going to happen to the lungs or the air in their lungs? They're going to pop, right? So again, all of these experiments ended up with a successful landing on the moon and future endeavors. So after going to the moon, NASA decided that they wanted to focus on low Earth orbit and staying closer to Earth by using vehicles like this. Okay? So this is the Space Shuttle Orbiter Enterprise, and it's located at the Intrepid Museum on the flight deck at the far end in the Space Shuttle Pavilion, right? But back when we were talking about capsules, those capsules would go up into space, they'd come back down, they couldn't be reused again. But great thing about shuttles is they could be used over and over and multiple times. It could be recycled and reused. Now, I hope this doesn't ruin your day, but Space Shuttle Enterprise never went up into outer space. The highest it ever went was about 26,000 feet, about 470 miles per hour. So not very high, not very fast during its approach and landing tests, or ALTs. right? If you've ever been in an airplane, you've probably been higher than Enterprise. But this led to kind of learning again about those baby steps. Think about Enterprise, like I said, it never went into outer space because it was a prototype. It was the first one ever built. Again, we need to take those baby steps and make sure that things work before we send them up without testing it. So, great thing about Enterprise is that it went up on a 747 jet. It separated, and basically NASA wanted to see, could this space shuttle come back into the atmosphere and glide back down like an airplane? Thinking about those shuttles that landed in the ocean, it's really easy to pick those up. But think about a shuttle landing in the ocean. It's going to be very, very difficult to pick that up out of the water. But what's really great about the shuttles is they have landing gear. They have wings. So they're able to glide in the atmosphere and land on a runway just like an airplane. And NASA would have never known that if they hadn't built the first prototype and tested it out to make sure that it could actually work. Now, these shuttles basically work as large cargo ships. They could bring up things like pieces of the International Space Station and equipment like the Hubble Space Telescope. Its payload area could hold things about the size of a yellow school bus and about 50,000 pounds of payload. So shuttles after Enterprise were able to go up in a shuttle stack, right, where they had the actual shuttle, the solid rocket boosters, and the liquid fuel tank. And like I said, because Enterprise was the tester, it actually went up on the back of a 747 jet. Now, when the Intrepid received Space Shuttle Enterprise, it actually flew back in on a 747 jet, kind of did a wave around New York City, and did a good wave before coming to the Intrepid Museum. But after Space Shuttle Enterprise and all of its success, NASA was able to make a few more space shuttles afterwards, do 133 launches, but the last one in 2011 when the Space Shuttle was retired with Space Shuttle Atlantis. Now, like I said, Intrepid acquired the Space Shuttle Enterprise back in 2012. So if you were really disappointed about Enterprise not going up into outer space, at the museum, we do have something that did. Now, this is a Soyuz Russian spacecraft, and you can also see this actually underneath the Space Shuttle Enterprise in the Space Shuttle Pavilion at the museum. And you can kind of see here from this picture that it's a little toasty. Now, this is what astronauts use today to actually get to the International Space Station after retiring the space shuttles. It used to be the only way to get into space up until, of course, recently with SpaceX, which was the first crewed orbital spacecraft launched from the US since the final space shuttle mission. Now, it can hold 3 astronauts there, and you can kind of see that it looks pretty cozy, right? They've got a lot of what looks like cushion and fluff. These seats are actually made to form to their bodies so that they're as comfortable and cozy as they go up into space. Now, we talked about how the Mercury and Gemini capsules landed in the ocean. The space shuttles land on a runway. The Soyuz capsule actually lands in the desert of Kazakhstan, right on Russia's southern border. They still use a parachute, as you can see there, that opens up and kind of creates some drag to help them float back down safely to Earth. But it's also got these retro rockets underneath that are also going to give a little bit of extra boost to kind of slow them down as well as they're coming back down from outer space. So I think now is a good place to do a question break. There you go, make myself a little bit bigger. How many shuttles were created? So I said after Enterprise, we had 5 shuttles created with Enterprise, Columbia, Challenger, Discovery, Atlantis, and Endeavour. Enterprise was named after Starship, mouthful, with the other ones being named after historic sailing ships, which I think is very cool. Any other questions? Where are the other space shuttles today? So, of course, we know that Enterprise is located at the Intrepid Sea, Air, and Space Museum in New York City. We have Atlantis at the Kennedy Space Center down in Florida. We've got Discovery at the Udvar-Hazy Center in Virginia. and Endeavour at the California Science Center. Now, unfortunately, we lost Challenger during a launch and Columbia during a re-entry. But what's really neat about them being spread across the United States is no matter where you are, you're kind of close to a shuttle that you could possibly visit. Awesome. So as we discussed, it takes a lot to initially get up into space and get back down. NASA pushed that a little bit further by going to the moon and then focusing on low Earth orbit. But NASA is actually currently working on getting back to the moon. Now you're probably wondering, why are we going back to the moon? We've been there 6 times, like you just said, right? So NASA's venturing back to the moon to take the first woman and the next man to land on the moon, appropriately named Artemis, Apollo's twin sister, in 2024. And this is to help astronauts learn how to live longer and test technologies that are going to eventually get them to Mars, right? NASA is launching Artemis 1. Get that up there. There you go. Artemis 1 to be unmanned. It's going to head about 40,000 miles beyond the moon. Artemis 2 will take 4 astronauts and orbit the moon, return back to Earth, before sending Artemis 3, which is going to, which is going to send astronauts to possibly land on the moon in 2024. A gateway will also be going, which is basically going to be an outpost around the moon as well. But Mars is in the near future. So what does that look like? Well, because we're going to be venturing a little bit further, we're going to need more fuel, right? More fuel adds more weight. More weight means you need more fuel. So that's already the first challenge that needs to be considered. Next, you've got to think about the time. The most efficient way to get to Mars and save fuel is to basically jump orbits from Earth to Mars. And in order to do that, Earth and Mars have to be at very specific parts in their orbit. And this placement doesn't happen very often, so it has to be timed just right. Now, next is landing on the moon. Mars's atmosphere is very, very thin, right? We're going to be taking a lot more weight to Mars too, right? NASA has sent a couple of rovers that don't weigh a lot, so crash landing isn't a high possibility, but if you're taking a lot of weight, like astronauts and all the equipment, it's going to be a lot harder to land on Mars. And so just getting there and landing is a part of it. NASA also has to consider living and staying on Mars. The temperature, the gravity, the atmosphere are very, very different from Earth. The astronauts also have to bring a livable habitat along with them, with life support systems. And this is what NASA is going to be working on with the Artemis missions, is to eventually use all of their knowledge of basically living in a deep space environment at the moon and applying that to getting to Mars. Just like getting to the moon for the first time, everything they took from the Mercury and the Gemini missions were able to eventually get them to the moon. So in conclusion, right, just as early space missions are learning how to do the basics and learn the beginnings of space, right? NASA's still doing things like that today. And eventually, with everything that they've learned in the past, they're going to journey further than any human has ever gone before. So thank you, friends, for joining me today. Let me make myself a little bit bigger there. Ooh. The museum has introduced a number of live programs, and you can find those on our website at intrepidmuseum.org, or you can subscribe to our channel or follow us on Facebook. Our next program is going to be this Thursday, June 17th at 3 p.m. It's Africans Americans in the Navy. So join Intrepid as we highlight some of the remarkable men and women that have blazed the trail for African Americans in the Navy. The museum is open to the public Thursday through Sundays from 10 a.m. to 5 p.m. And starting June 21st, we're going to be open 7 days a week. So definitely come check out some of the really cool artifacts and aircraft that we have at the museum. Now, if you enjoyed this program, we invite you to answer a quick survey located in the chat. And once again, my name is Kara, and thank you for joining me on another Intrepid adventure. See you next time.